Hey guys, welcome to Pre-Calc Lesson 12.5, Limit Properties and Sketching. All right, we're going to first talk about limit operations and properties. So what we're given here is that the limit of f of x as x approaches b equals m. The limit of g of x as x approaches b is n. First property here is a scalar multiple. So if you notice, it looks very similar to the limit of f of x, except we've got this inside. It's called a scalar multiple. And all that's going to do is that's going to take our limit of f of x, which is m, and we're going to multiply it by that scalar, a. So the result here is going to be a times the limit of f of x as x approaches b, which is just m. Next, we've got sum or difference. All right, we'll talk about the sum first. If you notice here, we've got the limit of f of x plus g of x as x approaches b. Well, the limit of f of x as x approaches b is m. The limit of g of x as x approaches b is n. So as you guessed, we're just going to add those two results together. Now this works the same if it's a difference. So I'm just going to put like a plus or minus here because subtraction works the same as addition. And product or quotient, again, pretty straightforward. I'm guessing you guys are picking up on this concept. All we're going to do is take the limit of f of x as x approaches b, which is m, and the limit of g of x as x approaches b, which is n, and multiply those together. And again, same thing with division. All right, so pretty simple concept. Let's put to practice. All right, so given a limit of f of x as x approaches b is 7, the limit of g of x as x approaches b is negative 2, and the limit of h of x as x approaches b is 9. I want you guys to evaluate these limits. So for part A here, we've got a scalar multiple. So I'm going to bring that out, and I'm going to multiply that by whatever the limit of f of x is as x approaches b. Well, that's just 7. So my answer is going to be 3 times 7, or 21. Part B, limit of h of x squared as x approaches b. Well, here's the limit of h of x as x approaches b. That's 9. So you guessed it here. We're just going to square that. That gives me 81. Part C, a little bit more involved. It's just more arithmetic. It's not that much more challenging. I've got the limit of 8 times f of x plus 2 times g of x. All right, well, let's just write this out. It's going to be 8 times the limit of f of x, which is 7, plus 2 times the limit of g of x, which is negative 2. All right, so 8 times 7, 56. 2 times negative 2, negative 4. So that should give you 52. Similar concept here. We've got the limit of 4 times f of x. All right, 4 times f of x minus 2 times h of x. And let's just figure that out. I'm going to write down below here so I don't have much room. So 4 times f of x. The limit of f of x as x approaches b is 7. Minus 2 times h of x. So that limit is 9. And then we just have to evaluate this. So I think that's 28 minus 18. And we would get 10. A couple more. This is about as complicated as it's going to get. So inside my limit here, I've got h of x squared. All right, so there's h of x minus 7 times g of x. All right, so let's write that out. H of x, that limit is going to be 9. I'm going to square it. Minus 7 times the limit of g of x, which is negative 2. 9 squared, 81, plus 14, and I think that's going to give us 95. One more, I'm going to move on to a new topic. The last one here, I've got the limit as x approaches b of f of x squared over the limit of h of x minus 7 times the limit of g of x. All right, so the limit of f of x squared, that's going to be 7 squared, over the limit of h of x, that gives us 9, minus 7 times the limit of g of x, which is negative 2. So 7 squared, 49. That's going to be, what, 9 plus 14, which I believe is 23. 49 over 23, and we're just going to leave that as a fraction. Okay, next topic for today. Pretty simple concept here. There's not a lot of work. It's more conceptual. Sketch a function with the given limits. So we need to know what this means. The limit of f of x as x approaches 1, and then if you remember, that symbol right there means from the right. If you see the plus sign after the number, from the right. So basically, this is what it's saying. As you approach from the right, so as you come this way, you're going to end up at the point 1, 3. You're going to point to that, not end up there necessarily, but point to that. So this is what it looks like. Coming from the right, I need to end up at 1, 3. So we just have to sketch that. All right, so 1, 3 is that point there. And you just want to make sure that this is a function. So you can't do this, obviously, because that's not going to be a function. But anything else is fine. It can be a straight line. You can make it absolute value, quadratic. It doesn't matter. You just have to approach from the right and point to that coordinate 1, 3. All right, so our second one, this limit. Remember, that means from the left. So now we're approaching 1 from the left, and we have to end up at the -2 value, so right there. Okay, so let me just jot that down again. So that's going to be from the left. So now coming from the left, going this way, I'm going to point to 1, -2. Now here's where we have to be a little bit careful. I can't do this, 1, -2, and do that, all right? Because this is not a function. Remember, a function has to pass a vertical line test. So one of these 2 points, or both, need to be an open circle. All right, so if you're going to get confused as to which one, it doesn't matter which one, just one of them. Or they can both be open circles. It doesn't matter. You don't have to evaluate the function at one. Those limits just have to exist. So here's a great example. Next one. Sketch a function with the given limits. All right, so again, this right here, if it says x approaches 1 with a minus sign, we say x approaches 1 from the left. Okay, so from the left, I'm going to point to the coordinate 1, 3, because remember, the limit is the y value. Okay, and I'm going to go on and do the whole thing before I make my sketch. So this one here, from the right. So coming from the right, I need to point to 1, 5. Now this has something additional. This has f of 4 equals 0. What does that mean? That is a point, and that point is 4, 0. So my function must contain that point. Okay, I'm going to do from the left first. From the left, I've got point to 1, 3. Okay, so let me put that down, 1, 3. And again, this could be anything. It could be upside down absolute value. You could make it a quadratic. You could make it a linear. It doesn't matter. You just have to come from the left and point to that coordinate 1, 3. So now the next one's a little bit more challenging. Okay, from the right, I have to point to 1, 5. But I also have to contain the point 4, 0. Well, I can't do this because that fails a vertical line test. So the easiest way to do this is to go through the point 4, 0 and point to 1, 5. All right, so again, because I made this a closed circle, 1, 5 has to be open. I must go through the point 4, 0. And then I just draw anything that comes up to that. So from the left, I point to 1, 3. From the right, I point to 1, 5. And I contain the point 4, 0. That is the easiest way to do this. I'm going to skip to example 5. Example 4 is very similar to 3. This has got something new, though. The limit of f of x as x approaches 0 from the right is infinity. What does that mean? As we approach 0 from the right, the y value goes to infinity. So basically, that kind of indicates we have a vertical asymptote here. So anytime the y value goes to infinity or negative infinity, that indicates a vertical asymptote. But in this case, it's only from the right. Now I'm going to wait to sketch that in because there might be something else on that side of my axes that I have to pay attention to. So let's take a look at this one. This says the limit of f of x as x approaches 0, and that would be from the left, is 1. So from the left, you're going to point to the coordinate 0, 1. Remember, that doesn't mean you have to contain 0, 1. You're just pointing to that. And then lastly, down here, we talked about it in example 3. This gives us a coordinate. All right, so this right here is simply the point to -3. What I like to do, like I said, the last example I like to keep as easy as I can. So 2, -3 is going to be on my function. So whatever I have to do on this half of the graph, I want to go through this point. It's just the easiest way to do it. So now if you remember, what we said is on that side, I'm coming from the right, the y is going to approach infinity. So I'm going to have something that kind of looks like this. You can sketch in this asymptote. And just remember, I'm coming from the right. I'm going to go through that coordinate, and the y is going to go up to infinity. So what I've just done there is I've taken care of this limit and this point. So now all it's left to do is take care of this limit from the left. I got to point to 0, 1. So coming this way, I just have to point to 0, 1 right there. Now, because this is an asymptote, you can make this a closed circle or an open circle. It doesn't matter. You just need to sketch something that comes in here and ends up there. Okay, so I'll just, because I can, I'll make this a closed circle. And let's do some sort of sine or cosine. Perfect. All right, so basically what we've got covered here, the limit from the left points to 0, 1. The limit from the right goes to infinity. And we contain this point right here. All right, one more. So again, you might see something different here in the second. First couple look fairly normal. The limit of f of x as x approaches 2 from the left is 3. So again, from the left, I'm going to point to the coordinate 2, 3. From the left, I'm going to point to the coordinate 2, 3, something like that. But again, we've got some other parts here, so I'm not going to start the sketch yet. Let's see what else we have. So this one, as x approaches 2 from the right. So that's going to be from the right. So coming from the right, I'm going to point it to the coordinate 2, 5. Again, that doesn't mean that it contains 2, 5. That's just what I'm pointing at. Now we discussed this is the third time we're seeing it. That is a point. Okay, so that is simply the point 3, 4. And whenever I have a point, I like to put that on there first. So I have the coordinate 3, 4. I'm going to put that on the grid. Because I know the easiest thing to do is whatever my other limits are is to kind of go through that point. Now this one is new because notice what this says down here. The limit of f of x as x approaches infinity. So what does that mean as x approaches infinity? That means as x goes this way towards positive infinity. Well, that limit is 1. Remember, a limit is a y value. So that is going to be the y value as x approaches positive infinity. So basically when you see something like this, that's going to represent a horizontal asymptote. All right, and notice it's x approaches infinity. That's positive, so that means moving to the right. So what I'm going to do here is I'm going to put in a horizontal asymptote at y equals 1. Now I only need it on this part of the graph because remember, it's only an asymptote as you move to the right. As we move to the left, as x approaches negative infinity, we don't really know what's going on because it doesn't specify. So now let's put the pieces together. From the left, I have to approach the point 2, 3. All right, so 2, 3. Right here, I'm going to make that a closed circle. From the left, I have to approach that. Again, this can be anything. That looks good. From the right, I have to approach the point 2, 5. 2, 5. All right, so 2, 5. I want to make this an open circle. Remember, because I made this closed. So since this is closed, that has to be open. They can't both be closed. They can both be open. If that's easier, just make them both open. So now I have to create something that points to this, goes through this point, and approaches 1 as x goes to infinity. So again, I think the easiest thing to do here would be to sketch something that looks like this. Because this limit, as x approaches infinity, is going to be 1. It contains this point. Coming from the right, it points to 2, 5. And then this limit over here, coming from the left, it points to 2, 3. This is the hardest sketch you're going to have to make. Contains the horizontal asymptote, a point, 2 limits, right and left. But if you can do this one, you're going to be able to do anything that we throw at you. Okay, so that concludes lesson 12.5. Again, I just want to thank you guys for hanging in there and watching all these videos and doing the homework and submitting the required work. As usual, if you have any questions, feel free to reach out. Brave Square Schoology email. Thanks, guys.